In this video, we're going to take a look at how to name or write the formula for covalent compounds. So let's just jump right into it. Now, to name covalent compounds, it is different from ionic compounds because nonmetals can form a wide range of compounds using the same two elements. So a good example here is when nitrogen and oxygen combine together, it can form NO, it can form N2O, and it can form NO2. So if they're all made of N's and O's, but they're combined in different numbers, we can't call them all nitrogen oxide because we don't know which one's which. So we do need a system in order to be able to distinguish which version we have out of these three. And so the way that we do that is we use something called Greek prefixes. Now, what are Greek prefixes? Greek prefixes are Greek words that we basically add. So pre means before, and so we fix these Greek prefixes to the beginning of each of the elements' names. Now you do need to know these. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. One other thing to note is that the first element in our name, we never put the word mono in front of it. So we'll see that in a couple of examples in a minute. Okay, so let's take a look at some examples together. So we're going to take a look at this first one, N2O. So we're going to, again, identify this first element is nitrogen. But we have two of them. So we need to add di in front of the nitrogen. That's our Greek prefix. Our second element is oxygen or oxide. And then because there's just one of them, we need to add the mono in front of it, or it becomes dinitrogen monoxide. In the next one, CF4, we have one carbon. So we're just going to call this carbon. And remember I said we never put the mono in front of the first elements. We don't actually need the mono there. The second element, F, fluorine, becomes fluoride. And then because there's a 4 here, we need to add the tetra in front of the fluoride. So this becomes carbon tetrafluoride. And then finally, the last one, P2O3. So we have phosphorus, and we have two of them. So that is diphosphorus. And then our second one, oxygen, and we have three of them. So that becomes trioxide. So we're still using the IDE ending. We're still naming the first element and the second element. The only difference now is we're adding in these Greek prefixes where we need them. So we can go the opposite way too. We can take a name and come up with a formula. So our first example here, phosphorus pentafluoride. If we start with the phosphorus, find that on the periodic table, and that is a P. Now, because there's nothing in front of the phosphorus, it just tells us that there's one of them. The pentafluoride, we need to recognize that this is a fluorine, and the penta means 5. So the formula for this compound, and maybe I'll erase this P so I can bring it a bit closer, becomes PF5. If we look at the next one, dihydrogen dioxide, di means 2 and hydrogen, so we have H2. And then again, di means 2 and oxygen, so we have O2. So that's H2O2. Now, what if you have just one element? There are certain non-metal elements that are what we call diatomics. So what that means is they form a bond with themselves. These are all of our halogens, so iodine, bromine, chlorine, and fluorine, as well as oxygen, nitrogen, and hydrogen. So they never exist by themselves, but they always exist in what we call diatomic molecules, or basically they have a covalent bond. Now, you do need to memorize these. And there's a couple ways you can memorize which ones are diatomic. I kind of like this saying I, which stands for iodine, bring, which stands for bromine, and then chlorine, which is just chlorine. 4, if we take the F, that's fluorine. O for oxygen, our. Nu, that's nitrogen. And then H, hydrogen, our hot tub. So I bring chlorine for our new hot tub. Or you could just remember Hofbrinkel if you say them all together. That's another fun way that you can do it. Now, if you are asked for any of these different ones here, there's 7 of them, then if you're asked to write the formula, it's always got a 2 in it. If it's not one of these 7, then we say it's monoatomic, so it's just 1. So if I asked for helium gas, it would be just He, or neon gas would just be Ne, and so on. So knowing that, if we're asked for some of these, let's just go through some examples quickly. Helium gas, helium is not one of those 7, so we would just write He. And because it's telling us a gas, we could add in a state symbol of a G, and that tells us that we know it's a gas. Chlorine gas, recognizing chlorine is one of the diatomics, so that's Cl2, and again, it's a gas. If we have O2 with a gas, that's oxygen gas. And then Ne, whoops, we don't need the either. Ne would just be neon gas. So it's just being able to recognize your 7 diatomics and making sure that when you see those, you add the 2 to the formula. If not, you just write them singly. That's it then for this video. Let's move on to our next task.